The Auto Flight System, AFS, on the A320 family is designed for assisting the pilot in flying the aircraft within the normal flight envelope, hence enhancing safety and optimizing performance. This module is an introduction to the AFS. Let's begin by building up a basic conceptual diagram. The AFS could be represented as 4 main sections. At the heart of the system is a computation and processing section, the brain. The central processing section has access to several information sources. The pilots have access to the central processing section via input devices. Finally, after computation and processing, commands are provided to output devices.
For the AFS in the A320 family, computation and processing are done by 2 flight management guidance computers FMGCs. The 2 FMGCs are identical and normally work together, so for training purposes we will group them as the Flight Management Guidance System, FMGS.
The FMGS receives navigation information, which contains details of airfields, nav aids, airways, routes, waypoints, procedures, SIDS, stars, approaches, missed approaches, etc. Aircraft performance information, the Air Data and Inertial Reference System, ADIRS, and the Global Positioning System, GPS, for position and dynamic information. You will learn about them in the navigation chapter. The clock, radio navigation information. The pilots provide inputs to the FMGS using 2 multipurpose control and display units, MCDU, for long-term interventions, and a single flight control unit, FCU, for short-term interventions. The FMGS provide outputs to the flight directors, FDs, and autopilots, APs, for pitch, roll, and yaw control, the autothrust, ATHR, for thrust control, the MCDUs and EFIS for the display of information, and the navigation radios for the automatic tuning of radio aids. The FMGS is divided into 3 main parts: flight management, flight guidance, flight augmentation. The flight management part of the FMGS controls the following functions: navigation, the position of the aircraft and the estimated accuracy of this position; flight planning, the flight plan computation; performance optimization, costs, speeds, and altitude optimization; predictions, the accurate estimates for waypoints, altitudes, speeds, fuel, destinations, and alternates; display management, the control of information to the EFIS system to display auto flight modes and navigation information. The flight guidance part of the FMGS provides autopilot commands to automatically control pitch, roll, and yaw, auto thrust commands to automatically control thrust, flight director commands for the pilot to control the pitch, roll, and yaw.
The flight augmentation, FAC, part of the FMGS provides flight envelope computations, minimum speed, such as VLS, or maximum speed, such as VMO or VFE. Maneuvering speed computation, for example best speed to fly in a given flap configuration. Wind shear detection, which triggers the wind shear warning. Angle of attack protection, alpha floor protection, triggered when the aircraft's angle of attack is above a predetermined threshold. Note, the FAC has various yaw functions, such as yaw damping, term coordination, and others which will be reviewed in the Flight Controls chapter.
As a general rule, the two FMGCs have access to information provided by on-site sensors, except for certain parameters or in case of failures. They exchange information for validity comparison purposes. For example, information from MCDU-1 is received by FMGC-1 and transmitted to FMGC-2. All FMGCs and MCDUs are then synchronized. The inputs from the FCU are fed to both FMGCs. Both FMGCs send their commands to the FDs, the autopilots, and the autothrust system. According to a given internal logic, one FMGC is declared master. E.g., if autopilot 1 is on, FMGC 1 is master. Amongst other things, this determines which autothrust channel is operative.
The controls and indicators found in the cockpit are 1 Flight Control Unit FCU, 2 FD push buttons installed on the FS control panels and the associated FS displays, 2 multi-purpose control and display units MCDU, 2 thrust levers, mainly an interface with auto thrust.
You have just reviewed the overall presentation of the autoflight system. In the next modules, we will review each component in more detail. The Flight Control Unit, or FCU, is the short-term actions interface with the FMGS. It is used to arm or engage the guidance modes and to select their associated targets. It is also used to set the autopilots, APs, and/or autothrust, ATHR, on. The FCU has 2 channels. Each channel is able to drive the entire FCU. For the rest of this module, we will concentrate on the center part of the FCU.
The pilot uses the FCU to select targets and arm or engage their related modes for speed Mach, for lateral guidance, for example, heading, for vertical guidance, for example, vertical speed. The pilot also uses it to set the autopilots and autothrust to on. We can find, in the control areas, 4 selector knobs and their associated windows, as well as 2 mode engagement push buttons. As an option, a third one can be installed.
As a general rule, if you turn a selector knob, you select a guidance target. If you then pull the same knob, you engage a mode which will guide the aircraft to the selected target. Such a mode is a selected mode. The selected target is clearly displayed on the associated window and on the associated PFD scale using a blue target symbol. On the other hand, if you push a selector knob, you arm or engage a mode which will guide the aircraft to a target managed by the FMGS. Such a mode is a managed mode. In this case, the associated window, except the altitude one, displays dashes with a white dot. Let's now have a closer look at the Speed Mach section. The Speed Mach selector knob enables you to select the target speed for the autopilot or auto thrust.
This selection is done by turning the selector knob. The selected speed is then displayed on the window.
By pulling the speed knob, you engage the selected speed mode for the autopilot and/or auto thrust, which will guide the aircraft to the selected speed target. By pushing the speed knob, you engage the managed speed mode for autopilot and/or auto thrust. This will guide the aircraft to the managed speed target profile as computed by the FM. The speed window displays, in this case, dashes as well as an illuminated white managed speed Mach dot. The selection in the speed window can either be a speed or a Mach. In normal operation, the change from speed to Mach target occurs automatically in climb at around flight level 300 and vice versa in descent. However, you can toggle the selected target between speed and Mach by pushing the Speed Mach push button on the FCU at any time. The current selection is clearly indicated by a speed or Mach legend on the display. That is all for the Speed Mach area. Let's now learn more about the lateral area. Like the speed selector, the heading track can be turned, pulled, or pushed. By turning it, you select a heading or track target. We will see later on how to toggle between heading and track. By pulling it, you engage the selected heading or track mode for the autopilot flight director. By pushing it, you engage the managed navigation mode for the autopilot flight director, which will guide the aircraft along the active leg of the primary flight plan. In this case, the window displays dashes as well as an illuminated white managed lateral dot. The heading, vertical speed, track, flight path angle push button is used for the display of flight path vector, FPV, or bird on or off the PFD. When the bird is on, your flight reference is the flight path vector, the aircraft trajectory. When the bird is off, your flight reference is the attitude of the aircraft. The consequence for the autopilot flight director is that you change their basic guidance references from track, flight path angle, bird on, to heading, vertical speed, bird off. The flight reference selected here is attitude, bird off. The aircraft attitude symbol is your flight reference, and if the flight director is on, the flight director crossbars are displayed. The selection is also indicated by heading vertical speed legends on the FCU display. Change the reference. The selected flight reference is now the flight path vector, bird on. The bird symbol is your flight reference and materializes the aircraft current trajectory. If the flight director is on, the flight director flight path director, FPD, is displayed. The selection is now indicated by track flight path angle legends on the FCU display.
The vertical area is divided into two parts. The first one relates to the altitude. The second one relates to vertical speed or flight path angle guidance modes.
The altitude window is never dashed. It always displays the target altitude which is systematically selected by the crew as the next applicable clearance altitude.
This knob can also be pulled or pushed. By pulling it, you engage a selected vertical mode. It will guide the aircraft towards the FCU selected target altitude, while disregarding any altitude constraints of the vertical flight plan. By pushing it, you engage a managed vertical mode. It will guide the aircraft towards the FCU selected target altitude, matching all altitude constraints of the vertical flight plan, and along the pre-computed descent path. The white level change light comes on. Note: managed vertical mode can be engaged if the lateral profile is already managed.
This knob is actually two different selectors. The inner selector sets the altitude target in the window, and an outer ring changes the altitude increments. The increment-decrement of the altitude can have two settings, 100 feet or 1,000 feet. The metric altitude push button is also part of the altitude area. It has been already seen in the EIS chapter. We just remind you that this push button is used to display the selected altitude, written in meters, on the permanent data display area at the bottom of the ECAM system display, SD. Let's now have a look at the vertical speed flight path angle part. Here again, the vertical speed flight path angle selector knob has three functions. The first two are similar to what we've already seen. The turn function enables you to select a target vertical speed or flight path angle. The pull function enables you to engage the selected vertical speed or flight path angle mode. The third function, push, differs from the other push functions. In fact, when you push the selector knob, the FM commands an immediate level off. Vertical speed or flight path angle equals 0. The value 0 is then displayed in the window as well as on the FMA. To set a value, let's first turn the vertical speed flight path angle selector knob. Turn the vertical speed flight path angle selector knob.
As soon as the vertical speed flight path angle selector knob is turned, the vertical speed flight path angle window indicates the current flight path angle, or vertical speed. In this case, a flight path angle value is displayed. Notice how the degrees are displayed. The minus sign indicates a descent. A climb would be indicated by a plus sign. To engage the Autopilot Flight Director Flight Path Angle Selected mode, we have pulled the selector knob for you. For training purposes, we wish to change the flight reference, and thus select the bird off, changing the basic Autopilot Flight Director guidance references from flight path angle to vertical speed. Switch back to heading vertical speed.
The vertical speed window is now showing a vertical speed target, minus 800 feet per minute, synchronized with the current vertical speed. Notice how the vertical speed is displayed and the change of labels from flight path angle to vertical speed. The vertical speed flight path angle window can also display dashes if a vertical managed mode is engaged. This case will be seen and explained later in the course. Let's now take a brief look at the other push buttons located on the FCU. The lock push button, arms, engages the lock mode. In case the aircraft is cleared to intercept the localizer only, or in case of localizer only approach. When lock mode is armed engaged, the green lights on the push button are illuminated. You will see this function in more detail during your free play and simulator sessions.
The pilot uses the approach push button to arm engage the approach modes, depending upon the approach type selected in the FM's flight plan. When engaged, green lights come on the push button. If installed, the Expedite push button allows you to temporarily expedite the climb or descent towards the altitude selected on the FCU. The target speed is then automatically set to the best climb or descent speed in order to achieve that goal. When selected, green lights come on the push button.
Autopilot 1, Autopilot 2 push buttons set Autopilot 1 and/or Autopilot 2 to on. Autothrust push button sets Autothrust to on. The push button illuminates green when autothrust is on or when it is armed. See autothrust logic, e.g., as soon as takeoff power is applied. We will come back to these controls in a later module. Note, these push buttons may also be used for APs and/or autothrust setting to off, but in normal operation, this is not the recommended disconnection procedure. You have now seen an overview of the FCU. The FCU is basically a selector panel with various functions. Remember that one of our golden rules is know your FMA at all times, which means that any new selection made on the FCU should be confirmed on the FMA located on the PFD. Long-term actions through the MCDU and short-term actions through the FCU must be cross-checked on the Flight Mode Annunciator, FMA, located at the top of the PFD, as well as on the various scales of the PFD. The guidance mode engagement arm status and their associated guidance targets are provided on the FMA and PFD scales: speed, heading, altitude. When managed by the FMGS, the targets and modes are displayed on the FMA as the flight progresses. Let's discuss the FMA in more detail. As you can see, the FMA is divided into 5 columns.
The first column is dedicated to thrust. This is where the auto-thrust modes appear. The second one displays the vertical modes of the autopilot and flight directors. The third one, the lateral modes of the autopilot and flight directors. The fourth one gives the approach capability of the auto flight system and the radio or baro, with the related value as entered on the MCDU performance page. The last column displays the engagement status of the autopilots, flight directors and auto-thrust systems.
In certain cases, the second and third columns are combined to display a single autopilot flight director mode, which is common laterally and vertically. These modes are common modes for approach, which means that they are closely linked together. You will study all the modes in later modules. The FMA can display 3 lines in each column. Let's look at the first 3 columns. The first line shows the engaged modes to the flight guidance system. In our example, the speed mode is engaged for the autothrust. This means that the autothrust will manage the thrust to track the target speed. The altitude, ALT mode, is engaged for the vertical mode. This means the autopilot FDs will provide guidance to maintain altitude. The heading, HDG mode, is engaged for the lateral mode. This means the autopilot FDs will provide guidance to the selected heading. Note: the color coding will be explained later when the concept of managed guidance and selected guidance will be discussed. The second line shows armed modes for the flight guidance system. In the example shown, GS and LOC in blue indicate that glide slope and localizer capture modes are armed.
The third line shows reminders or messages and can be spread over one column or two columns. In our example, the column 2 and the column 3 are used for a special message, which advises us to check the consistency of selected approach. Note: for more details, refer to your FCOM.
When any mode changes on the FMA, it is boxed for a few seconds to draw the pilot's attention to this new status. In our example, the aircraft is intercepting the localizer. The star, after the lock indication, means that the aircraft is in the capture phase. Once established on the localizer, the indication becomes lock. Notice that the glide slope is still armed. We will be learning more and more about the FMA in the following modules, as we are constantly using it during all autoflight operations. In this module, we will review how to turn the autopilots and/or the FDs on. First, let us review how to engage the autopilot. Autopilot on. You are the captain and pilot flying. The autopilot is an assistance to the pilot to fly the aircraft. The autopilot works within the aircraft normal flight envelope. Therefore, the pilot can turn it on whenever the aircraft is within this flight envelope. Here, we are just airborne, above 100 feet from the ground. Engage Autopilot 1. The FMA confirms the engagement of Autopilot 1. As a general rule, when the captain is pilot flying, Autopilot 1 is used. When the first officer is pilot flying, Autopilot 2 is used. This ensures that each autopilot will be alternatively operated. The autopilot can be used just after liftoff from, say, 100 feet until the end of the landing rollout. In most cases, only one autopilot can be engaged at a time.
However, in case of an ILS automatic approach, both autopilots may be turned on at the same time. This ensures the best level of redundancy required to safely achieve auto lands, auto rollouts, or low-altitude go-arounds. As a consequence, once cleared for an ILS approach, the pilot presses the approach push button to arm localizer and glide slope modes. The second autopilot may then be turned on. AP2 push button has been pressed to on. The FMA confirms the engagement status of both autopilots, as well as the resulting level of redundancy achieved, dual. This will dictate the minimum possible DH. You will see this in more detail in the guidance mode modules. Now, let us review how to disconnect or turn the autopilot off.
You are now flying an automatic approach. When in sight of the runway, you decide to take over manually. To turn the autopilot off, you press the red Autopilot Disconnect push button, also known as Takeover push button, located on either side stick. The weather is fine. You are number 1 for approach. Disconnect the autopilot.
Turning an autopilot off via the takeover push button triggers the following temporary warnings. A cavalry charge or a warning for around 1 second. The master warning flashing several seconds. An autopilot off red message on the right column of the engine warning display, several seconds. By pressing the takeover push button again, you will cancel all these warnings immediately.
Notice that, on the FCU, the autopilot's lights are extinguished. On the FMA, Autopilot 1 plus 2 is no longer displayed. The approach capability is downgraded to Cat 1, and on the ECAM system, all warnings are now off.
The recommended technique to set autopilots off is to press the autopilot disconnect push button on a side stick. They can also be set to off by acting on the side stick or rudder pedals with a force beyond a given threshold, or pressing an autopilot push button on the FCU when the corresponding autopilot is on. These last two actions lead to a repetitive cavalry charge, a permanent activation of the master warning, and a permanent red autopilot off warning on the left column of the engine warning display. This is considered by the flight guidance as an involuntary autopilot disconnection.
The FG also drives the Flight Director FD symbols displayed on either PFD. The Flight Director is an assistance provided to the pilots to accurately hand-fly the aircraft along a given segment of a trajectory. The Flight Director provides guidance orders to the pilots as a function of the guidance modes and targets selected on the FCU. These orders are materialized by specific symbols, e.g. crossbars. The Flight Director symbols are displayed on either PFD. The symbols on PFD1 are driven by FG1. Those on PFD2 are driven by FG2. The engagement status of the Flight Director is indicated on the FMA. Here the Flight Director symbols are called crossbars and are referenced to the aircraft attitude symbol. To turn the Flight Director on or off, use the Flight Director push button located on either EFIS control panel. When a Flight Director is on, the green bars of the corresponding push button are illuminated. Here both FDs are on. Let's turn them off. Each pilot presses his Flight Director push button. Flight Director bars are removed from the PFD. Flight Director engagement status is cleared on the FMA. Flight Director push button green lights are extinguished. Note that we have switched the Autopilot 1 off for you. When both autopilots and FDs are off, note that all mode fields, except the one of the autothrust, here Mach, are blank on the FMA. It is important to notice that if both FDs are set to off, while autopilots are off, autothrust, if active, is automatically in speed mode or Mach mode. Let's now turn the FDs back on. Suppose that the captain presses his flight director push button first, and then the first officer. Flight Director 1 is on. The crossbars are displayed on PFD 1. The FMA on both PFDs indicates 1 Flight Director as Flight Director Engagement Status, meaning that only Flight Director 1 is on. The Flight Director 1 associated modes. Notice that Flight Director 1 push button illuminates in green on the EFIS control panel. Let us now turn the first officer's flight director back on. Note, when both autopilots and FDs are off, and you turn one of them back on again, it comes up in basic modes: vertical speed heading or flight path angle track. Both FDs are now on. The crossbars are displayed on PFD 2. Both FMAs indicate 1 Flight Director 2 as Flight Director Engagement Status, meaning that both FDs are on. The on-side Flight Director Guidance modes. Note that Flight Director 2 push button illuminates in green on the EFIS control panel. As a general rule, it is strongly recommended to set both FDs on or off at the same time.
Let's review the flight director symbols. The flight director crossbars are two independent bars, referring to the aircraft attitude symbol, a horizontal bar, indicating the pitch command, and a vertical bar, indicating the roll command. The roll bar is replaced by a yaw bar index for takeoff and landing roll-out functions from an ILS-equipped runway. The yaw bar helps the pilot to properly track the localizer on ground while in low visibility condition.
The principle of the Flight Director crossbars has been reviewed in the EFIS module. Let's review another Flight Director symbology.
We have seen the Flight Director crossbar symbology, referring to the aircraft attitude symbol. The other Flight Director symbology refers to the flight path vector, FPV or bird. The bird can be displayed on/off on the PFD by pressing the heading vertical speed track flight path angle push button on the FCU. Click on the heading vertical speed track flight path angle push button.
Notice that on the PFD, the bird is now displayed. On the FCU, the indications have been modified to reflect the change to track flight path angle. Let's have a closer look at the PFD. The flight path vector, FPV, is displayed. The crossbars are removed and replaced by the flight path director, FPD, referenced to the flight path vector. In case flight director bars are displayed and the guidance modes are vertical speed and/or heading, these modes are automatically changed to track flight path angle if you select the bird on. Have a look while we do this for you. First, check that flight path vector is displayed. You can see that the mode changes are outlined on the FMA with white boxes. Notice also that the heading target has been changed to a properly synchronized track target. Let's see an example of a manual track change. We will concentrate on the PFD. When flying manually, the objective is to center and align the flight path vector on the FPD. We will turn onto a track of 140. The FPD commands a roll to turn onto the selected track. The aircraft is rolled until the flight path vector and FPD are aligned. Approaching track 140, the FPD demands a roll to level the wings. When in track flight path angle, the FPD reverts to flight director bars in case of go-around. You will practice the use of the flight path vector and the FPD and the simulator. We will now look at how the flight guidance achieves its automatic thrust control function, the auto thrust system or auto thrust. The auto thrust can work in two different modes. Speed mode. The auto thrust continuously adjusts the thrust in order to maintain a target speed or Mach, e.g. during cruise or approach. Thrust mode. The auto thrust sets a given thrust, e.g. max climb or idle. The auto thrust modes are automatically linked to autopilot flight director vertical modes. When autopilot flight director vertical mode controls a trajectory, e.g. altitude hold, vertical speed, glide slope, the auto thrust is in speed mode. When autopilot flight director vertical mode adjusts the aircraft pitch in order to keep a target speed or Mach, e.g. climb, descent, the auto thrust is in thrust mode. The main auto thrust controls available for the pilots are the thrust levers. On the Airbus fly-by-wire family, the auto thrust does not back drive the thrust levers while it adjusts the thrust. Let's have a closer look at them.
When the auto thrust is off, the crew controls the thrust as usual by moving the thrust levers over a quadrant. For forward thrust, this quadrant carries 4 physical detents or stops, which are idle, climb for max climb thrust, flex MCT for flex thrust at takeoff or max continuous thrust, toga for max takeoff or go around thrust.
The auto thrust can only work when the thrust levers are set forward of the idle detent and up to the climb detent, or MCT detent in case of engine failure. If the thrust levers are set by the pilot in the reverse position, the auto thrust cannot operate. Note, the alpha floor function is an exception which will be covered later on. When auto thrust is on, the thrust lever position determines the maximum thrust which can be commanded by the auto thrust, for example, to accelerate in speed mode. On the thrust gauge, which we will be talking about in the engine chapter, the thrust lever position is indicated by a symbol. It materializes the maximum thrust available for the auto thrust in a normal operation. The auto thrust has 3 states. It can be either disconnected or off, armed, ready to be set to on by a specific pilot action on the thrust levers, active or on. Let's see these states in more detail. We are taxiing to the runway. Because we are on the ground, the auto thrust is necessarily disconnected. This is confirmed by the absence of any auto thrust related indications on the FMA and by the extinguished auto thrust push button on the FCU. Thrust is manually adjusted by the crew as required to taxi the aircraft. You are cleared for takeoff. The pilot flying must manually set the thrust levers to flex or toga to initiate the takeoff roll. Click on the thrust levers to initiate the takeoff roll. As soon as the thrust levers are set in the toga position, the FMA shows auto thrust blue, indicating that auto thrust is armed, manual toga white, indicating that the pilot manually controls the thrust via the thrust levers set in toga. Note: toga is the maximum thrust available for takeoff. At the same time, on the FCU, the auto thrust push button light illuminates in green. The fact that the auto thrust is armed means that it is ready to be engaged by a pilot action on the thrust levers. Note that when the auto thrust is armed, the pilot has manual control on the thrust with the thrust levers.
Crossing the thrust reduction altitude, the pilot must manually set the thrust levers to climb detent. On the FMA, a flashing lever climb prompts the pilot to set the thrust levers back into climb detent. We will set climb thrust for you.
Notice that on the FMA, auto thrust white indicates that the auto thrust is on. Thrust climb green indicates that the auto thrust is in thrust mode. Since the thrust levers are set to climb and the autopilot commands a climb mode, the auto thrust commands thrust climb. The white boxes around the modes highlight the fact that a mode change has occurred on the FMA. Note: the Autopilot 1 vertical mode adjusts the pitch to maintain the takeoff scheduled target speed. In normal operation, when autothrust is on, the levers are left in the climb detent throughout the flight until the flare. The autothrust adjusts the thrust as required between idle and max climb, but the thrust levers, not being back-driven by the autothrust, remain in the climb detent as set by the pilots. Crossing the acceleration altitude, AC-alt, the FM climb phase is initiated. The autothrust maintains climb thrust, while the vertical mode, climb, adjusts the pitch to accelerate the aircraft towards the new speed target. The initial climb speed here is 250 knots.
If, at any moment, the pilot needs some additional thrust, he will push the thrust levers forward from climb detent. He will then manually control the thrust. In that case, man thrust is displayed in white on the FMA, auto thrust is displayed in blue, since the auto thrust is armed. Whenever the pilot brings the thrust levers back into climb detent, the auto thrust is automatically back on in the applicable mode. Note that the auto thrust may be on in flight, provided the thrust levers are set above idle to climb detent, all engines operating, or above idle to MCT, one engine inoperative. Beyond these detents, the pilot has manual control on the thrust.
When the aircraft reaches the target altitude, Autopilot Flight Director switches to altitude mode. The autothrust switches to speed, Mach mode, as indicated on the FMA. In this mode, the autothrust continuously adjusts the thrust to maintain the target speed, Mach. Autothrust is also in speed mode when Autopilot Flight Director vertical modes are vertical speed or flight path angle, GS, and generally during the approach. We are now in approach, just before flare. You fly the aircraft manually with the autothrust engaged.
Note that the autothrust is in speed mode. During a hand-flown flare, the pilot has to reduce the thrust for landing. He will do so by bringing the thrust levers back to idle, at about 20 feet. Note, if he does not do so, The auto thrust will increase thrust to maintain the speed. A retard auto call-out comes up at about 20 feet as a reminder to retard the thrust levers.
Thrust levers are now set to idle. This turns the auto thrust off. Note that on the FMA, the white auto thrust indication is no longer displayed. The FMA auto thrust column is blank. On the FCU, the auto thrust push button is now extinguished. We have just seen how to turn the auto thrust off by setting the thrust levers back to idle for landing. The recommended procedure to set the auto thrust off in flight in order to avoid any thrust change at auto thrust disconnection is 1. To move the thrust levers back so that the thrust lever position symbol roughly matches the present N1 or EPR. 2. To press the instinctive disconnect push button located on the thrust levers. Note: pressing at least one push button for more than 15 seconds will inhibit the auto thrust, including alpha floor protection, for the remainder of the flight. When the auto thrust is off during flight, in order to turn it on again, press the auto thrust push button on the FCU, with the thrust levers in or below climb detent. Note: you can disconnect the auto thrust by pressing the auto thrust push button on the FCU. This is not the standard recommended procedure.